Hey guys, good morning. Hope you're enjoying the rain. So I just wanted to read you this question from yesterday because there was some confusion on it. So this guy sprays vans and cars, as if vans are not cars, but okay. So sprays vans and cars. It's called the vans X and the cars Y. It says it takes 3 hours to spray a van and a car 2 hours. So that'll be 3x plus 2y, and he says he must spray for at least 15 hours a week. That's greater or equal to 15. He must spray at least 3 times as many cars as vans. At least, so because of at least, we know the symbol has to be that one. But since they've said 3 times as many cars, so if he sprays one van, then he must have sprayed 3 cars. So they also say that he must spray not more than 8 cars in a week. So the cars are Y, they should not be more than 8. The other obvious ones are X greater than 0 and Y greater than 0, which I'll use as restrictions. Now when I graph this on Desmos, I already went ahead and graphed it. When I graph this on Desmos, this is what I get. That little intersection, which you can see better in this graph here, that intersection can be seen better. I just used a few more restrictions so that you can see that intersection. That's the wanted region, the intersection of all of those inequalities. So the points on the outer edges, those points on the outer edges are the ones that help you to easily or quickly get things like the maximum number of cars he can spray, or if the question was asking you for profit, those points on the outer edges would be the first places to start. So this question asks us to graph them. We've graphed them. It also asks us to determine what's the maximum number of cars he can spray. Well, that maximum number is going to be on the outer edges of the wanted region. On the outer edges of the wanted region have this point 0.8. They also have the point 0.7.5. So what I'm going to do is I'll just go ahead and start adding the x and y values of those points. So if I add the x and y values of those end points, the one that gives me the highest total is this point right here, 24.8. So I'm going to know that there is no point in this wanted region which will give me a higher value than 24.8. So every time you're looking for something that maximizes the situation, first thing you do is look for points on the outermost points of the wanted region. If there are no distinctive points on the outermost wanted region, then you can use the points inside the wanted region that are distinctive. So for example, I would have been able to use this one, or here I would have been able to use that one. If they didn't intersect at a very good point, I would have used, the next one, which would have been that one or that one, to check for the maximum. So that was question 1. That was question 2 from yesterday. One I want to do today with you is this one here. The shopkeeper buys 2 types of feeds, and type A costs 7,500, type B costs 6,000. She has 15,000 available and decides to buy at least 18 kilograms altogether. So let's first figure out the equations. Obviously, if I call type A X and I call type B Y, my very first equation will be 7,500X plus 6,000Y is less or equal to 15,000. My second equation will be, she wants to buy at least 18 kilograms altogether. So when I add items of X and items of Y, should be at least 18 kilograms altogether. So at least is greater or equal to 18. She decides to buy at least 16 kgs of type A feed. So A, just A by itself, must be at least 6 kgs. She makes a profit of 2,000 shillings per kilogram of type A and 2,500 per kilogram of type B. So let me write a profit equation here. check that again. Profit of 2000 per type A and 2500 per type B. So the profit equation, I can get my profit using 2500x plus 2000y. Did I get it right? No, it's 2000. What's wrong? 2000 and 2500. So 2000x plus 2500y. That's the profit equation. What else do they want me to do? Show these inequalities on the graph. I'm going to do that. Assuming she can sell, find how many she should sell to maximize profits. So this is kind of the point of me doing this for you, so that you can see how you can maximize profits. It's very similar to the previous example. So I'm going to go ahead and graph these on Desmos. So let me just pause this for now. So I've graphed my equations, and this is what I've come up with. Going back to my question, it asked me, assuming she can sell all the feed, how many kilograms should she buy to maximize her profits and how much the profit is? So I'm going to go to the graph, and like I said, I'll look for those points. First, look for the points at the edge of the wanted region. So those points are this one right here, 6.0, and this one right here, 18.0, I think. Yeah, so that's the one. This one, 18.0, and then that one up there, 6.12. So I'll substitute those values of x and y into this profit equation. So I'll first try the first one. X is 6, y is 0. Definitely is not going to give me the biggest answer. I can also try 6, 12, and I'll check 2000 times 6, 2500 times 12. Does it give me a better profit than the other last one, which was 18.0? 18.0. So let's check those ones. 2000 times 6 plus 2500 times 12. That gives me 31,200. Oh, that's 2000. And if I check the other one, so this one gives her a profit of 42,000. But if I check the other one, 18.0, 2000 times 18, and this one times 0, that one gives her a profit of 61,000. So yeah, I think this is what would give her the biggest profit. 18 of type A and 0 of type B. Yeah, so there you have it.